Today we're actually going to read and answer questions solving a scatter plot. So if we look at number 1, it's actually just a review from Thursday. So if we are looking at this, it says, which of the scatter plots do not suggest a linear relationship? Remember, linear is a straight line. So if I am looking at that, which one of those would not give me a straight line? If you pick this one and this one, you are correct. If we look at this one right here, it does suggest a straight line. It would be a zero slope if we looked at it as a slope aspect, but it would be a straight line. Okay, so now we're going to learn how to draw a best fit line. A best fit line goes through the middle of your dots. You're not going to connect the dots. You are just drawing a best fit line through the points. And it will be in the middle of the points. Okay, so if I look at this, based on the scatter plot, what is the best prediction of an average number of minutes a person would read each night to get 100 on their fluency exam? So we want to go to the grade, so you have to read to know what they are doing. We're looking for the minute. That is our question. That is what we're looking for. So we want a grade of 100. So we go across and hit our line and go down. And about where are we at? Well, if you look right here, you can see every other line is 10. So that would be 45, and this would be 55. So as you see right there, our answer would be 55. So now let's look at this graph again for this information and think about what we did on Thursday. Write a conclusion. Which inclusion best supports the scatter plot? So let's talk about this. Is this a positive, negative, or no correlation? It is a positive. So when it is a positive, I need my two words to say the exact same thing. So if I look right here, this one says a number of minutes of reading increases as the grade of the fluency test decreases. That would be a negative slope. That is not what I have. If I look at the next one, as the number of minutes of reading decrease, the grade of the fluency test increases. That one is also a negative slope. C, as the number of minutes of reading increases, the grade of the fluency stays the same. You see that is not staying the same. It is a positive slope, so that one is also not correct. That graph would have looked more like something right over here. As the number of minutes of reading increases, the grade of the fluency test increases. Increase and increase means a positive slope. Okay, so our next one. The scatter plot shows a relationship between the height and age of teenage girls, and then it has your height and age as your label, height on your y-axis, and age in years on your x-axis. So I'm going to draw my best fit line. Do you see how my line is in the middle of my dots? It's a little curvy, sorry about that. It is just a straight line. You can actually on the STAR test draw a straight line and then you can actually move it. Makes it perfect, makes it nice and neat. Then you can make sure it's right there in the middle. Now we're going to read and figure out which axis I need to start on. Based on the scatter plot, what is the best prediction of an average of a height of a 14-year-old girl? So I'm going to age of a 14. I'm going to go up and hit my line, and I'm going to go across. And my answer is 62. We actually did this when we were reading graphs, so it's nothing different. The only thing you must do is draw your best fit line first. And be careful when you draw your best fit line. So as we're looking at number 5, which statement are the best supported this scatter plot? Choose 2. Okay, so it is a positive slope. So I know I need increase and increase. So if I look at here, increase, increase. Oh, I bet that's one of my answers because as the girl's age increase, the height increases. That makes sense. As the girl's age decrease, the inches increase. No, because a positive and a negative keep a negative. As the age of the girls decrease, the height stays the same. It is not staying the same. We know it's a positive slope, so we know that's not it. As the girl's age decrease, the height decreases. So if I read that backwards, a 17-year-old girl is taller than a 12-year-old. So as her age decreases, gets smaller, doesn't she get shorter? Doesn't her height decrease? So a decrease and a decrease, a negative and a negative make a positive. So like we talked on Thursday, if it is talking about the same thing, it would also be an increase or a positive slope. This one, as the height of the girls increase, the age decreases. We know if there's 2 different ones, that is a negative slope. Okay, we're going to skip number 6 right now. We will come back to that if we have time. We'll do that at the end. The scatter plot shows the relationship between the average daily temperature and the number of visitors at the beach. Based on the scatter plot, what is the best prediction of the number of visitors that would come to the beach on a day with a temperature of 90 degrees? Okay, so here we go. Draw your best fit line. Ooh, that one's a little curvy, so I'm going to start over. And I think you have a line tool on there. You could try to figure that out if you want to. Okay. The scatter plot shows the relationship between the average daily temperature and the number of visitors at the beach. Based on the scatter plot, what is the best prediction of the number of visitors that would be at the beach on a temperature of 90 degrees? So as I look at my graph, I see that my temperature is going 88, that would be 90, and then 92. So I'm going to go up and hit my line, and I'm going to go across. Well, that's about 375. Okay, so if I look at my answer choices, which one of those answers would be closest to 375? You are correct, 450. If you do not want to guess on that, you can actually redraw your best fit line. I probably didn't draw mine height enough, so I could draw it. And if I go to 90 and up, as you see right there, I hit it exactly. So you might just need to adjust your line. Mine looks better now. That's why it's really nice. If we are doing this digital, you can move that line and you don't have to erase. So that does make it easier. Okay, we have the next one. A scatter plot shows the relationship between the long distance call and the cost of the call. And this is now, based on the scatter plot, what is the best prediction for the cost of the long distance call to last 115 minutes? Okay, so if I'm at 115, this would be 90, this would be 110. So 115 is going to be out here. So I'm going to go up and hit my line, and I'm going to go across. Ooh, my lines are not straight. Now, that would be 9, 10, 11. I'm not going to be to 12 yet, but I'm in between 11 and 12. So which answer choice would you pick? 1150. You are correct. You could also half the 115 and go from there, go up and hit your line, and then double your cost of call if your number goes too far off the graph. Okay, number one, back to what we did Thursday. Which of these does not suggest a linear relationship? B is correct. Now, these are how you would see them on the STAR test. They're probably going to be the drag or drops. If we're looking at the scatter plot, the data shows the hours at 6 a.m. increase. The number of donuts customers purchase do what? They decrease because it is a negative slope. So if one increases, the other one decreases. The relationship between the hours since 6 a.m. and the donuts purchased, is it linear? It sure is. And is it a positive or negative correlation? We've already said it is negative. So as you said the other day, we were talking about association. Today they're talking about correlation. Those are the same things. They're talking about positive or negative correlation or association, so you can use the words anyway. Oh, let's just review our finding a slope and y-intercept. So let's first find our y-intercept. Remember, our y goes up and down. So where is it crossing my y-axis? At positive 2. It is above 0, 0, so automatically I know it's positive, and positive 2. Just by looking at that, I can get rid of two answers. Then let's talk about this. Is it a positive or negative slope? It is a negative slope. So right then and there, I can get rid of A. So I bet my answer is D. But let's test it out. Here's another pretty point. I can rise and run. I'm rising 2 and I'm running 1. So yes, negative 2 is the slope and your y-intercept is 2. You try number 4, pause the video, draw your best fit line, and you're going to actually answer 2 questions on this. I could totally see them doing this on the STAR test. Then they can get 2 questions out of 1. Once you finish, you can turn the video back on. Hopefully you really paused the video to practice your skills of a best fit line and getting the answers correct. So let's see if you got them correct. The scatter plot shows the relationship between the length in feet and the age in years of great white sharks. Complete each statement to make a reasonable prediction about the data shown in the scatter plot by drawing a line to form a correct answer to each box. We're just going to put the answers in the box. So let's draw our best fit line. And now we can answer our questions. A shark that is 10 years old. I'm going to 10. I'm going to go up and hit my line. And I'm going to go over. About how old is he? I'm between 24 and 27, but closer to 27. So I bet he'd be 26 feet long. Now, let's look at our next question. A shark that is 21 feet long. So now do you see they're making you go from your y-axis? I'm going to go across and hit my line. And I'm going to, let me see if I can draw that line straighter. And I'm going to go down. And where am I? I am closest to 7. So I would say 7 years. Okay. We could have been good with that in class, so we might not have gone to this, but we're going to go ahead and look at this so it is on the video. Drag a purple dot to the scatter plot. We're actually going to draw a purple dot, so you might need to find a purple dot. I'm actually going to change my purple dot to a green dot. Okay, drag the purple dot, we're going to say green dot, on the scatter plot to show your prediction of a weekly gas for someone who commutes 20 miles. Well, I can draw a best fit line here. And if I was going 20 miles, let me get my green dot, I would be about right there. So my answer would be what? 25. Now I'm going to take a red dot, drag a red dot to the scatter plot that shows your prediction of a daily who spends $45 in gas. So we are over here and we're going to 45 and we're going to go the closest on our line, which would be 45 miles. Now we'll drag a blue dot to show your prediction of a weekly gas cost for someone who commutes 30 miles. So as you see, you have to watch and see which axis you're starting on, or they're going to have that answer there to get you. If I am going 35, oops, wrong line. If I am going 30 miles, I'm at a cost of 35. Okay, these are perfect ones. We can draw best fit lines on these. As you see, my line is in the middle of my dots. When X is 9, remember this is your X, this is your Y. When X is 9, Y is about 32, 33. That would work. They would have to have choices here for you on this one to move, and they would not have 32 and 33, so you would be okay there. If Y is 15, then X is about 18, 19. When X is 2, Y is 12, or if yours is closer to 13, I would take that. So if I was doing something like this and I didn't give you answer choices, I would have a window of numbers that would be okay. Because not everybody's going to draw the exact same best fit line. We have 17. When my X would be, you could go with 5.5, you could go with 5 or 6. I would be totally okay with both of those. You might be exactly on 5. So that would be totally okay. When X is 12, I'm going to redraw that line. That one is really messy. If you find that line tool up there, it might be a lot more handy because my lines are not wanting to work this morning. Oh, there we go. I think that one might be good. Okay. So if we're at X is 12, I'm going to go up. And Y could be 40, 41, whatever you chose, the closest to your line. Remember, I would take a window. They're going to have matching on this, so you would be okay. Or they would have to take a window of numbers. If Y is 60, X is 8. And the next one, as you see, you have answer choices. If a tree is 4 years old, which is the best prediction of the height? So I go to age is 4, and I go across, and it should be about 6. If a tree is 10 feet tall, so now I go to my Y, the height of 10, I'm at 7. So which would you pick when you have 12, 8, and 10? 8, because it's your closest answer. If a tree is 6 years old, and if you make a thicker line, it might help. If your tree is 6 years old, which is not a reasonable amount? Okay, so I'm between 8 and 9. So if you have 7 and 9, that would be okay. Do you see 5 would not be a reasonable amount? So do you see how they would take 7 or 9? Okay, let's figure out these and figure who is who. So at least with digital, you can sit there and play with those numbers. Okay, Genevieve says when X is 9, Y is 9. When X is 9, not that one. When X is 9, not that one. Oh, not that one. When X is 9, ooh, right there. That is Genevieve. Paloma predicts that when Y is 20, X is 10. So Y is 20. That one's not going to give you 10. Y is 20. I bet X is 10. There's Paloma. Kareem predicts when X is 2, Y is 18. There's Kareem. And hopefully this last one is Jonah. When Jonah predicts Y is 10 and X is 25. Okay, let's go back to this one we skipped. And it says mean absolute deviation. This is just a review of MAD. So remember, you are going to make your 3 columns. We are going to write our numbers down. I want you to pause the video and add those up. Pause the video and add those up. And you should have got 368.75. Now remember, we've got to take the average of those, so we add it up, and we're going to divide by 1, 2, 3, 4, 5, and 6, because it says 6 girls. Whatever I divide by there, I will also divide by here. So my mean for that was 61.46. So I'm going to take this whole column and subtract 61.46 from it all the way down. So you're going to pick up your calculator and you are going to subtract 62.5 minus 61.46, and you get 1.04. You are going to take 60 and subtract 61.46 and get 1.46. You're going to take 61.25 and subtract 61.46 and get 0.25. You're going to take 60 and subtract 61.46 and get 1.46. You're going to take 63 and subtract 61.46. And you are going to get 1.54. You are now going to take 62 and subtract 61.46 and get 54. Now you are going to add up that last column. So you can pause the video and add up the last column. And you should get 6.25. You're going to take that and divide by 6. And it says rounded to the nearest hundredth. So I have this as my number. So before I round to the nearest hundredth, hundredth is my second place behind the decimal. So I need to look at the third. It's 4 or less, so I let that 4 rest. I look at the 1. 1 is 4 or less, so I let that 4 rest. And your mean absolute deviation is 1.04. So I averaged, subtract, average. You're done. That's a review from what we did way back then.